Hello and welcome to the Online College of Coding video tutorial for Plasma Possum Intermediate. I'll be your host, Daniel. In this video, we'll be going through creating Plasma Possum Intermediate in GameMaker Studio. Before you tackle this project, it's recommended that you've seen the Intermediate Programming Concepts video and the Introduction to GameMaker videos. That said, let's get started. Hello and welcome to the Online College of Coding's Plasma Possum tutorial. This tutorial is the intermediate difficulty version and uses the GameMaker Studio game development engine. Plasma Possum is a 2D platformer based off the Nintendo's original arcade smash hit Donkey Kong Arcade. An asset package containing all the sprites and sounds required to build this project can be found on the Online College of Coding's website. You can change the theme of GameMaker Studio by navigating to File, Preferences. The default theme for GameMaker Studio is GM Green, and the theme I'll be using throughout this tutorial is GM8. You will need to restart GameMaker Studio for a theme change to take effect. Step 1. Creating platforms. The first thing we'll create for our game is the platforms. Platforms are built from smaller individual pieces that we'll call rungs. The platforms are a logical place to start, as without them, the player would fall down off the screen. Here, we'll be creating the rungs, sprite, and object, as well as starting work on our level. Let's begin. Create a new sprite named SPR Rung. Then, load the rung sprite and set the origin to X48 and Y0. Create a new object named OBJ Rung. Then, set the sprite to SPR Rung. Now create a new room. In the Settings tab, set the width and height to 1920 by 1080, or whatever your screen size is currently set to. Then, place a row of object rungs along the bottom of the room, and then remove the very first rung on the left side. This gap is necessary so that the barrels can fall down off the screen. Next, open the Global Game Settings. In the Windows tab, you can change the display name, version number, icon, and splash screen. In that same tab, open the Graphics tab and enable the Start in Full Screen mode, along with Use Synchronization to avoid tearing. Step 2. Creating the player. Next, we'll create the most interactive part of our game, the player character Plasma Possum. To achieve this, we will need to create the player's idle sprites and the object itself. We will also need to program the first few features into our player. Let's get into it. Create a new sprite named SPR Player Idle. Load the 24 player idle sprites. Then center the origin point by clicking on the center button. Modify the mask and set the bounding box to manual, and then set the following parameters: left to 97, right to 142, top to 46, bottom to 128. Create a new sprite named SPR Player Run. Load the 24 player run sprites and then center the origin point. Next, create a new sprite named SPR Player Climb. Load the 8 player climb sprites and set the origin point to X58 and Y125. Now create another sprite named SPR Player Climb Idle. Load the 24 player climb idle sprites and center the origin point. Create a new object and name it OBJ Player. Then set the sprite to SPR Player Idle, and then set the mask to the same. We'll also be setting the depth to -5. Next, we want to add a new key press escape event. We're then going to drag in the end game action. Now add the create event. Here, we're going to run the execute code action that can be found in the control tab. It's common for objects with code to require variables to perform tasks. Here, we're adding the base variables that the player will need just to be able to move, climb, fall, and jump. Once we have our variables declared, our function we write next will be able to use them. Now add the step event, followed by the execute code action. Here we are giving the player his required code to be able to walk and jump, fall with gravity, collide with the rungs both vertically and horizontally, and of course, flipping the sprite when we change direction. The different colors of GameMaker language code all represent something different. Green is a comment, orange is a function, red is an object name or a built-in variable. Everything else is grey. Open your room and place an instance of your player on the rungs. You can change the scale X value to -1 if you want your player to face the opposite way. You may find that you need to raise your player up slightly from the rung so that he isn't stuck when the game starts. You can move your object smoothly by holding Alt. Now is the perfect opportunity to playtest your game and test if your player can move around. Step 3. Climbing vines. Our next step is to create the vines for our player to be able to climb. The vines will be placed and stretched between each platform. The player climbs whenever the user presses and holds W, while touching a ladder. To achieve all this, we'll need to create the sprites and objects as well as program in the climbing behavior into our player. Let's get started. So to start, create a new sprite and name it SPR Vine. Load the Vine sprite and then set the origin point to X7, Y30. Next, create a new object and name it OBJ Vine. Then, set the sprite to Sprite Vine and set the depth to -1. Now it's time to edit our level again. We're going to place another 5 rows of rungs, leaving an alternate gap with each one so that the jellies will be able to roll from the top all the way down to the very bottom platform where they'll finally roll off the level. We'll also need to add in our OBJ vines. Add as many as you like. Using the corners of the object when it's selected, you can stretch the object to your desired size. Make sure that the ladder starts at the top of both rungs it's connected to. Now it's time to give our player the ability to climb. Open Object Player, and within the Create event, select and open the existing Execute Code action. Here, we're going to give our player a new variable called Player State. This variable will control whether the player is currently running or climbing. Next, select the step event and open the Execute Code action. Here, we're going to wrap the entire existing code within the following if statement. By doing so, we're ensuring that this script will not run whenever the player is in a different state. While still in the player's movement script, we need to add a way for the player to begin climbing. Add the following above the sprite code and below the vertical collision code. Here, we're simply checking that the player is holding the correct direction. Then we check if there is in fact a vine on the player's current position, and then we change the player's state. Now that we can enter the climbing behavior, next we have to actually add the climbing behavior. While still in the player's step event, drag in a new execute code action following the existing one, and then add the following code. While climbing, the player only needs a few features, including moving, exiting the climb when you reach either the top or bottom, and changing the player's sprite while the movement button is down. Now's the perfect time to playtest your game. Test if you can climb up and down your ladders. Step 4. Rolling jellies. Finally, it's time to begin work on our first enemy, the jellies. The jellies are spawned at the top of our level from the crocodile enemy. They then roll down the platforms, one by one, until they reach the final platform, where they fall down off the level, despawning. Whenever a jelly comes into contact with a vine beneath it, a 1 in 10 chance is rolled to change into the falling state. It then resumes its movement state once it's fallen enough distance to clear the platform it was on. First, create a new sprite and name it SPR_jelly. Then, load the 23 jelly sprites. Set the origin to X46 and Y65 Then finally, modify the collision mask, set the shape to precise and the alpha tolerance to 100. Now, create a new object and name it obj_jelly. Then set the sprite to SPR jelly, set the depth to -4, and then add the outside room event, followed by the destroy instance action. Next, add the create event, followed by an execute code action, and add the following code. Just like the player, our jelly needs some variables to operate. It also needs to know which direction it should start moving in. Next, add the step event, followed by the execute code action, then add the following code to it. Here, we're giving our jellies much of the same of what we gave to the player in the beginning. Things like movement, gravity, horizontal and vertical collision. But our jellies also need a screen bounds bounce and a way to enter into its falling state. Now that we have our movement code all good, we need to code what the jelly does when in the falling state. So add another execute code action after the first and then add the following code. We only need to apply gravity and check for when we have fallen far enough to bypass the platform it was on and then go back to the original movement state. Duplicate SPR jelly and name it SPR EXP jelly. The EXP is short for explosion. Then, load in the 23 EXP jelly sprites, set the origin to X46 and Y65, then modify the collision mask, set the shape to precise and the alpha tolerance to 100. Now duplicate OBJ jelly and name it OBJ exp jelly. Set the sprite to be SPR exp jelly. Next, create a new sprite named SPR croc idle. Load the 20 croc idle sprites and then set the origin to 59 on the X and 102 on the Y. Now create a new sprite named SPR croc spit. Then load the 18 croc spit sprites and then set the origin point to X74 and Y116. Now to create our crocodile object. Our croc sits up the top, spitting out jellies or X jellies at random intervals. He also shoots a guaranteed X jelly when the game first starts. Create a new object named OBJ croc. Then set the sprite to SPR croc idle. First add the create event. Now add the set alarm action, and instead of specifying a number, we're going to tell it to generate a random number with the random range function, giving it the minimum value of 0 and the maximum value of 180. We'll also add a create instance action, setting the object to OBJXJelly and the XY coordinates to X and Y, respectively. Next, add the alarm 0 event, followed by the change sprite action, with the sprite set to SPR croc spit and the subimage set to 0 and the speed set to 1. Now we need to roll a 1 in 10 chance, so add the test chance action and set its sides to 10. Following that, add the start and end action blocks twice. Separate the two sets by the else action. Inside the first start and end block, add the create instance action with the object set to object XJelly and X and Y set to X and Y respectively. Inside the second block, add a create instance action with the object set to the object Jelly and set XY to XY respectively. And finally, after the second block ends, add the set alarm 0 with the steps set to, again, the random range function with the minimum set to 0 and the max set to 180. And our last event is the step event. Add the execute code action and then add the following code. Here, we're getting the croc to return to his idle animation once the spit animation has finished. Open up your level and place an OBJ croc up at the top left of the level. You can change the scale X value to -1 to flip the object when he's selected in the room. You should now have a working crocodile and jellies. Test out your game to see if they're working correctly. Step 5. Creeping crabs. Crabs are our final type of enemies. They are spawned into the world when an explosive jelly touches the crab hole. These little guys walk around, changing direction at random times, making them hard to predict and jump over. They will also climb up or down a ladder if the player is above or below them, meaning there is no escape from them. They will eventually get you if you spend too long in one place. Let's get into it. Create a new sound named SND crab spawn and load the crab spawn audio file. Create a new sprite named SPR crab and load the 25 crab sprites. Then set the origin point to center and modify the mask, setting the shape to precise and the alpha tolerance to 155. Next, create a new object named OBJ crab. Set its sprite to SPR crab and set its depth to -4. First, add the create event, followed by the execute code action. Then add the following code. Just like our other objects, here we're setting the variables that our crab will require while operating, and we'll also find the initial movement direction. Following our execute code action, add the set alarm action for the alarm 0, and we're going to set the number of steps to the random range function, with the minimum being 0 and the max being 120. Following that, we're going to add the play sound action for the SND crab spawn. The next event will be the alarm 0 event, followed by an execute code action. Then add the following code. Here, we are simply reversing the crab's direction. Now add the set alarm action for alarm 0, with the number of steps set to the random range function, with 0 being the minimum and 120 being the max. Our next event is the step event, and of course, here we're going to add the execute code action again. Again, here we're doing much of the same for the crab as we have for the other objects. We're giving it gravity, the ability to move, horizontal and vertical collision, a direction flip when it's about to step off the rung, as well as the ability to enter the climb state. Next, add another execute code action for the following climbing code. While climbing up, we continue climbing up until we find the top of the rung above. If we're moving down, we continue until the top of the second rung we come across, as we need to pass the rung we're standing on before we reach the destination. Now that our crabs exist, we need to edit the object jelly and object X jelly to always fall on a vine if a crab hasn't yet spawned. So, open object jelly, and in the step event, open the movement execute code action, and change line 42. You'll also need to do the exact same thing for object X jelly. We still need to create the objects the crabs spawn from. Create a new sprite and name it SPR crab hole. Then, load the 32 crab hole sprites, set the origin to its center, and modify the mask, setting the shape to precise and the alpha tolerance to 145. Next, create a new object and name it obj crabhole, and set the sprite to SPR crabhole, and set the depth to -4. Add the create event, followed by the execute code action for the following code. Here we're simply stopping the animation from playing. Now add the collision event with the obj exp jelly. Then, add the destroy instance action, however change the applies to other. Then, add the create instance action, setting the object to obj crab and the x and y values to x and y respectively. Now finally add the change sprite action, with the sprite set to SPR crabhole and the speed set to 1. Now we need to make sure the animation stops after it's played once, so add the step event. Following that, add the test expression action, with the expression set to image index is equal to 31. Then add the start and end block actions, and then in between those, add the change sprite action, with the sprite set to crabhole and the speed set to 0. Now open your level and place the obj crabhole just before the final fall on the bottom platform. Set its x and y scale to 2. Note that if the spawned crabs can't move, then you'll need to raise the crabhole up from the rung a little. You should now have fully functional crabs. Make sure to playtest your game and check that those crabs are spawning when the purple jelly hits the crabhole, and that they can move around and climb. Step 6. Scoring. Scorekeeping gives our game objectives for the player to complete, as well as a way of keeping track of how far and how well you've done. There are a few different ways you can earn points that we'll be setting up in this step. Not only will we have to create the collectible object and add the jump checking code to the player, but we will also need to create an object to draw your current score to the screen, as well as another object to show the amount of points just collected. The player will also be able to obtain points via smashing enemies with the hammer, and by completing a level via collecting the blossom. However, we won't be focusing on these objects in this step. They come in step 7. Let's begin. First, create a new object named obj pop-up points, and set its depth to -6. Now add the create event, followed by a set alarm action for alarm 0, set to 45 steps. Now add an alarm 0 event, followed by the destroy instance action. Now add the draw event, followed by the set color action. You can use any color you like here. Then add the draw text action, with the text set to 100 and the x and y set to x and y respectively. Now create a new sprite and name it SPR collectible. Load the 34 collectible sprites and set the origin point to the center. Then, modify the collision mask, setting the shape to precise and the alpha tolerance to 150. Now create a new sound named SND collectible, then load the collectible audio file. Now create the object named obj collectible, set its sprite to sprite collectible, and set the depth to -6. Next, add the collision event with the object player. Following that, we're going to add the play sound action that will play the sound collectible. We'll then add the create instance action that will create object pop-up points, with the x and y set to x and y respectively. We'll then set the score to relative 100. We then want to destroy the instance of self. Now let's get our points drawing on screen. Create a new object named obj game manager. The first event that we'll add will be the create event, followed by an execute code action for a following one-liner. Here, we are simply creating a new global variable called GameState and setting it to 0. This variable will control if the game is currently playing or paused. And now we'll add the draw event for our draw score action. Set the x and y to x and y respectively, and you can set the caption to be anything you'd like, even empty if you want, or you can just leave it as score. And now finally, we need to add an instance of our object game manager into our level. Remember that every level you create will need an instance of the game manager, and where you place your game manager is where your score value will be drawn on screen. Now that we have our collectibles, Let's get them to spawn into our world by themselves. Open Object Rung and add the Create event. Following that, we're going to add the Test Chance action with 10 sides. Following that, we're going to add the Open block and End block actions. Inside those actions, we're going to add the Create Instance action, setting the object to Object Collectible and the X to X plus sprite width divide 2 and the Y to Y minus sprite height. Next, we're going to create a new sound and name it S&D Player Jump. Then load the Player Jump audio file. Next, we're going to add both our jump sound and a way of earning points for jumping an enemy. Open your object player and in the Create event, open the Initialize Execute Code action. For our jumping points feature, we only need to know where the player first started to jump on the Y-axis. Next, select the Step event. Then open the Movement Executing Code action. Inside and at the bottom of the jump if statement, add the following. This simply plays our jump sound and remembers the starting Y position of the jump. While still in the Movement Execute Code action, move outside the jump if statement and add the following. Here, we're using the jump position Y variable to check if there's a jelly, X-jelly or crab in that location. And if there is, then we create an instance of the pop-up points, increment the score by 100, set the jump variable on our enemy to jump so that we can't jump him and get the same points again, and then we also play our audio sound. Congratulations, you should now be able to see your score on screen, jump enemies for points, and collect the collectibles for points. Step 7. Fighting back. Our next step is to create the hammer power-up that will allow us to finally fight back against our enemies. For this, we're going to require a pop sprite and object, as well as the hammer sprite and object. We will also have to code the hammer, as well as code a new state for the player, the hammering state. We'll also be creating a freeze effect while the pop animation plays, using the global game state variable we created earlier on in the game manager. First, we'll create a new sprite named SPR Pop. Load the 12 pop sprites, and then set the origin position to X 128 and Y 160. And now to create OBJ Pop. Set the sprite to the sprite pop, and the depth to -7. Then add the Create event, followed by the Execute Code action for a one-liner. Here we're simply slowing down the image speed, down to 50%. Our next event will be the Step event. Then add the Test Expression action with the following expression: image underscore index is equal to 11. Following the expression, we're going to add the Start and End block actions. Inside those block actions, we're going to add the Execute Code action for yet another one-liner, global.gamestate equals 0. We then want to add the Set Score action with the score set to 100 and relative enabled. Following that, we're going to add the Create Instance action with the object set to object pop-up points and X and Y set to X and Y respectively. Finally, our last action here, we want the Destroy Instance action. Now it's time to start working on our hammer. First, create a new sprite named SPR Hammer. Load the two hammer sprites, set the origin point to X 45 and Y 75, and finally modify the mask, setting the shape to precise and the alpha tolerance to 175. Our hammer feature is going to have 3 different sound files used. Create a new sound named S&D Hammer Collect, loading the Hammer Collect audio file. Then create a second sound file named S&D Hammer Expiring, loading the Hammer Expiring audio file. Thirdly, create a new sound named S&D hammer hit and loading the hammer hit audio file. Now to create the actual hammer object. Create a new object named obj hammer. Then set the sprite to SPR hammer. Set its depth to -5 and then add the create event, followed by an execute code action for the following variables. Next, add the step event, followed by an execute code action for the following code. Here, we're keeping track of the hammer's lifetime counter, and we get it to delete itself when it's finished. We also make the hammer change sprites back and forth when it's near its end to signify this to the player. Now we need a new collision event with Object Jelly. First, add the test expression action with the expression active is equal to true. Following that, we're going to add the start and end blocks. Inside those blocks, we're going to want an execute code action for another one-liner, global.gamestate equals 1. We're then going to add the create instance action for object pop, but instead of x and y, this time we're going to use other.x and other.y. Then add the play sound action. Set the sound to S&D hammer hit. Finally, we're going to add the destroy instance action with the applies to checkbox set to other. Next, we want to duplicate that collision event that we just created with Object Jelly for both Object X Jelly and the Object Crab. Now's a good time to open your level and add as many hammers to your level as you'd like. Be careful though, as you can't climb with a hammer, and you can still be killed by being touched. Next, we're going to create a new sound named SND BGM. BGM often stands for background music. Load the BGM audio file and set the attribute to be compressed, not streamed in memory, higher CPU. Create a new sound again, this one named SND player spawn, and load the player spawn audio file. Now it's time to edit our player so that he can hold and use the hammer. Open obj player and in the create event, edit the execute code action and add the following code. Now move over to the step event. Here, we're going to add a third execute code action, and in it, we're going to define the entire hammering state. Just like the player's other behaviors, we give him input, movement, gravity, horizontal and vertical collision, but we're not going to give him the ability to climb. We're also going to give him a sprite flip, both for the player and the hammer. Next, encapsulate the 3 execute code actions with a start and end block action. Then, place a test expression action above the starting of those blocks. The expression will be global.gamestate is equals to 0. This ensures that none of the player's behavior will operate while in the paused game state. Now add a collision event with the object hammer, followed by an execute code action for the following code. Here we're telling our player which hammer object in the game he's holding, plus we're changing the player to the hammering state. Next, select the create event and add the play sound action for sound BGM, Make sure that loop is set to true for this one. Following that, add another play sound action for sound player spawn. Now it's about time we added in death for our player. Now add a collision event with the object jelly. Then add the stop sound action for the background music. Then add the restart game action. Now duplicate the collision event with that object jelly for both X jelly and object crab. You'll also want to duplicate that same event, but this time into an other outside room event. This finally allows our player to die. Next, open Object Jelly. Inside the step event, wrap the scripts within the start and end block actions. Then, add the test expression action above the start block with the expression global.gameState is equal to 0. This completely stops the jelly's script from running while the game state is set to paused. Now we need to do the exact same thing to the X jelly, crab, and croc. Now that you've reached the end of step 7, now is a great time to playtest your game and check that those hammers are working. You should be able to crush both the jellies and X jellies and the crab. Step 8. Completing the level. Finally, the last feature our game needs is the ability to finish a level. For this, we will add the Blossom object, which when collected will move the player onto the next level. So first, create a new sprite named SPR Blossom, then load the 25 Blossom sprites and modify its mask, setting the shape to precise and the alpha tolerance to 222. Then set the origin point to its center. Next, create a new sound named SND Blossom Collect. Then load the Blossom Collect audio file and set the attribute to compressed, not streamed, in-memory higher CPU. Now create a new object named OBJ Blossom. Then set the sprite to SPR Blossom. First, add the create event followed by the execute code action for a one-liner. Collected equals false. Now add the step event followed by the execute code action for the following code. Here we are simply saying that once collected is equal to true and the audio file is not playing and the next room does in fact exist, then move to that next room. The next and final event our Blossom needs is a collision event with the object player. Then add the test expression action with the expression set to collected is equal to false. Following that, add the start and end block actions, and inside those actions, we're going to add an execute code action for a one-liner, collected equals true. Following that, we're going to add the set score action for a relative 1000 points. Then add the stop sound action for the sound background. Then add the play sound action for sound Blossom Collect. And now finally, for your very last step, open your level and add your object Blossom to the top of your level. You'll need to collect this to finish your level, but bear in mind you only have one level at the moment, so it's up to you to create more levels. Congratulations! You've finished the Plasma Possum Intermediate Game Maker tutorial. Using the techniques and knowledge you've learnt throughout this tutorial, you should now be able to move forward and create the next levels for your game. Remember, a good game starts off simple and progressively becomes harder. Once you've finished developing all the levels you would like, navigate to File, Create Application, to create an executable file. An executable file is your entire GameMaker project compiled together into a standalone version of your game, meaning it won't need GameMaker installed or open to run. When choosing where to place your executable file, you can use the Save As Type drop-down box to change which kind of executable file you would like. The default is an installer package, which when run, will require the user to install your game before it's playable. To avoid this, you can simply change the type to single runtime executable.